Okay, hello to everybody. I would like to introduce myself first. My name is Peter Siebert, and I'm with the DVB Project Office. And I would like to welcome everybody to our webinar on next generation audio today. Next generation audio is a topic which kept us busy in DVB within quite a while. But last year in November, we finalized our toolbox, and we have now solutions like AC4, DTS UHD, and MPEG-H in our toolbox. And I'm very happy that today, with the support of the proponents of these three systems, meaning Wolfgang from Dolby, Adrian from Fraunhofer, and Ted from DTS, and with the very good support of Simon Tuff from BBC, who will bring us through the slides, we can present now this webinar on next generation audio. And I hope you will find the next minutes, the next half hour as informative, interesting, and exciting. And with this, I would like to hand over to Simon. So Simon, can you bring us through the topic of next generation audio?
Thank you, Peter. Yes, good afternoon and welcome everyone. As Peter said, my name's Simon Tuff. I'm part of the technology team at the BBC, and we've been working as a group over the last few weeks to prepare this presentation for you. I hope it's going to be interesting, and I hope it's going to answer some of the questions you probably have about next generation audio. So what exactly is NGA? Well, it's not the spaghetti monster. It's not come from nowhere. In fact, it's been a thing that many people across many organizations have been working on for a large number of years. It comes from a lot of established technologies and workflows. It's using bits and pieces, components that you're probably familiar with already, and the object of the next half an hour or so is to share that with you and hopefully engage your enthusiasm for a topic that we're all very passionate about. Where does it sit in standards? Let's start with standards. This is a DVB presentation after all, and standards are at the heart of what DVB is about. We'll start with a couple from the EBU. For those people, there are quite a few EBU documents that support what we're talking about in terms of the DVB component, but the whole ecosystem of next generation audio is supported by EBU activity at the moment, and as well as these two documents on sort of policy and adoption, the EBU has documents on renderers, on profiles, and on other components, including methodologies for producing NGA content. There's also, as you might expect, a big range of international standards documents, MPEG-H mostly through ISO EEC, and as well as that there are the ETSI documents describing Dolby and DTS's technology. And then there are the ETSI specific documents for DVB. So at the heart of this lies the DVB toolbox in TS 101.154. But as well as that, we've got components existing so that the technology is ready for MPEG-, and the specification for service information in EN 30468. So a range of documents with lots of detail. Now, we're not going to dig into the detail this afternoon, but that's given you some indication if you want to find out where it is, where to go looking. So let's have a quick look at how we got to publishing all those documents. The DVB components in the toolbox, in that ETSI specification TS 101.154, the first in was AC4, shortly followed by MPEG-H, and they were both agreed together right back in I think actually they were approved at the beginning of 2018 and then made it into the Blue Book publication towards the end of that year. TS 103.285, you can see the same sort of progression as the technologies were adopted into the toolbox. So both of these for AC4 and MPEG-H at the beginning of 2018, and then DTS UHD in the first quarter of this year. And similarly for the service information in 30468, this information actually started earlier, as you can see with those, but DTS's UHD finally caught up at the beginning of this year. So all three of those technologies are now in those ETSI specifications, and it's all there ready for people to deploy. So what happens next? Well, what's it all about, really? What is next generation audio and why is it so different? And this is where we started off. This is a graphical representation that my BBC R&D colleagues have developed, but I think it describes really well how we used to work. We took all the bits and pieces that we needed in part one to make a program. We decided how they were going to go together. We assembled them into that program. We inserted that program, in this case it's the BBC test card, into the bit stream. In this case, item 3, the cardboard box. So one example was prepared from its bits, polished to perfection, put into the bit stream, sent to the home. But increasingly the home is, or the consumer is not necessarily even in the home. There's a range of different devices and experiences that the consumer want, but they're only getting one presentation of it. So invariably, that one presentation doesn't work so well. In fact, in sometimes not at all, in all the different ways that consumers want to use it. So that's part of the challenge that NGA and the next generation of technologies is all about trying to address. So this is fundamentally starting to meet some commercial needs. And the DVB spent a lot of time in its commercial module considering those commercial implications in some detail. And I think this is a process that probably in total took nearly 2 years, certainly about a year and a half, probably started back in the later parts of 2015. For those of you that are DVB members, this is well worth going to have a look at because it describes in some detail, and it will build on the stuff that we're talking about this afternoon, what those commercial imperatives are, and you can see how all these different technologies in the toolbox meet those key DVB commercial requirements. And it also expands on some of the use cases that they're designed to meet. So what are the experiences that people are looking to unlock using this technology? So how does it do it? Here we go, same version of the drawing, but with some significant differences. We start with all the same components. So in essence, we're still making programs the way we always made programs, and we've still got the same big pile of bits. But now, crucially, we package all those different components up individually, and we send with all those individual components a set of instructions. So when it reaches the receiver, we've got atomized content in the various key components, all in their own bit streams, all ready to be used, and a set of instructions that tell us how to put them all together. So we can now optimize that experience depending upon the device or the situation that the user finds themselves in. Fantastic. That's what it's all about. So that is the key takeaway from next generation audio. What are the benefits of this? What does it allow us to unlock? Well, we've categorized the 4 different sorts of experiences that are now available into 4 different types. Immersive. Well, audio has become increasingly immersive over the years with the introduction of high definition. Obviously, we added surround sound, and that definitely enhanced the experience. But now, crucially, NGA allows you to do a whole load more. It's adaptable. You can optimize it for the playback device. It's accessible. It allows you to improve experiences, particularly for those who have a hearing impairment or something similar, and it allows multi-language deployments as well. I know that some of us are doing this already with current DVB technologies, but it's quite a lot harder. It's considerably less flexible, and it's adjustable so that people can put their own preferences on and they can adjust some of the components to optimize the experience for their own personal viewing and listening experience. So it's now a truly impersonalized experience. Let's go back to the beginning and look at the immersive one in a bit more detail. So the most immersive experiences that you're likely to encounter are in the cinema, and certainly some of these technologies and certainly some of these approaches are optimized for films. Hollywood produces some amazing immersive experience, but it's a lot more than that. And as we'll see later on, there are now a significant range of technologies that allow truly immersive experiences in the home. And this is not just about having to screw lots of loudspeakers to all the surfaces in your living room and then carefully adjust all your furniture to make it to work. The latest generation of soundbar technologies from a range of suppliers using NGA techniques deliver quite spectacular results. And if you haven't heard one, I recommend that you go to a trade show or we get in touch with some of the providers of this technology and have a listen. It's quite an impressive experience. But it's not just about the Hollywood movie type experience. Immersion can work quite well in other scenarios. The DVB the EBU, I do beg your pardon, the EBU recently undertook a series of experiments with the full range of UHD technologies, including high definition, high frame rate 4K cameras at the European Championships in Berlin. This is the amazing athletics center in Berlin. And when this is full of people, the sound energy in a space like this is really quite something. And being able to take this experience to the home using NGA technology, which is exactly what the EBU team did, collaboration across the industry this summer, was quite a thing. Once again, if you get a chance to listen or see some of this EBU content, I utterly recommend it. It gives you a much better impression of what you can achieve, particularly with immersion, than my descriptions ever could. So let's get on to those other ones, because immersion's kind of taken as a given. We're building on what high definition can do. But what about personalization and accessibility? One of my colleagues here was very keen to express this as an equation, and this is what that equation might look like. It brings all of these capacities together as personalization. So you can adjust it, you can make it accessible, and you can adapt it for the environment in which you find yourself. So let's give some examples of this. Let's not just talk about the theory. This is a drama made by the BBC. It was developed as a radio drama, and it was done as part of a European Horizon 2020 funded project called Orpheus, where the listener at home can change their point of view of the drama. So there are three main characters that you can say on the left-hand side, and using the object-based component of next generation audio, you're able to follow this drama either as a listening point as Bill, as Dee, or Leslie. And it's a drama that you can follow different characters or indeed different rooms in the house, in the dwelling that the drama takes place. So it's adjustable to your personal view and the way you want to approach the story. There are other things to consider in this space, though. Here's some data that some of my BBC colleagues have managed to get for me, and this shows the number of contacts we've had from our audience around the audio component of BBC drama. And as you can see, in 2015, there's a bit of a sharp kick. Now, what we think is happening here, quite interestingly, this was about the time when loudness techniques, as outlined by the EBU's R128 guidelines recommendation, started to be delivered to our listeners at home in beginning of 2015. And we think two things happened at this point over the next year as loudness technology came in. The first was that all the complaints we previously had largely focused on level hops, you know, the jumps between dramas and news and music programs and trails and that sort of thing. And we'd largely kind of fixed that problem using the loudness techniques recommended in R128. So people were then saying, well, you know, those level jumps have been fixed, but the dialogue is now not so good. So they shifted their focus. And the other thing that happened was that because of the way that R128 works, we were giving people a much wider dynamic range within the program, or at least parts of the program, for them to try and explore. So in 2016 and adjusted again in 2017, we brought in a set of recommendations and guidelines about how that dialogue track should be balanced, particularly in the dubbing theatres, with the rest of the presentation, so that the dialogue became more intelligible. So that's one kind of fix, but what it shows us also is that dialogue intelligibility is a really key problem. And there are lots of other things, as most of us know, going on under the hood here. As displays become thinner and thinner, the audio challenges of getting loudspeakers into those displays and pointing them towards the listener become increasingly high. And we're seeing all sorts of mixes that present a dialogue challenge here. NGA gives you some of the tools to allow users to go in there and instead of going to their email and sending you a complaint, adjust it to their circumstances, their receiver, their hearing impairment, whatever it is, and improve the experience. So that's quite interesting. And we experimented with doing this back in 2011 at Wimbledon. And here you can see a fairly rudimentary but very clear user interface, allowing the user to adjust the level of commentary relative to the court ambience. And quite interestingly, one of the things we found about this is those people who use this interface to adjust between the two either wanted to hear quite a lot more commentary because they wanted to hear what the announcers were telling them about the game, or they wanted to get more of a sense of being there and they wanted more of the ambience. Now, admittedly, it's a bit of a self-selecting group, but it had two big response peaks in the way that people were positioning that fader on the slider between -3 and +3, and they were both skewed out in either more commentary or more effects. So I think there's a real user audience appetite for this sort of control. What else? Well, let's look at Adaptable. This is an example, once again, I mentioned the Orpheus project earlier on, and this is a user interface for a mobile phone of how adaptability using next generation audio techniques might look to the user. We kind of assume and we kind of balance most of the time for people sat in a living room listening at home. But we know that user behaviors are changing and increasingly people want to listen in other places or during other points of the day. So this particular interface gives you the opportunity to select a profile that will modify the audio that you're delivered for different experiences. It'll focus on the train, possibly, where you might have a lot of background noise, or it might be while you're taking exercise, for example, cycling. Also, it allows you to listen on headphones. You might change the experience for a headphone listener. And it allows you to develop your own particular profile. So if you find a set of settings that work for you or certain situations in which you find yourself, you can develop individual profiles and save those as well. So it's pretty adaptable. One of the key concepts that we need to talk about at this point is the concept of rendering. Now, this is a document, a diagram, sorry, that is features in a couple of EBU reports, and we've borrowed it for the purpose of this presentation, developed by Florian Camera at ORF. But what it shows you is how the new audio world is thinking about assembling all the components and passing them through to playback. So if we look on the production side, on the left-hand side of this slide, we can see all the usual components that you might expect, the different channels of a traditional audio presentation. And we can see, first of all, we can see the objects, all the individual audio components, and they're presented to a mixer who generates the channels. But they're also presented to a metadata generator, which is going to generate all this data that we talked about that allows the receiver to render the audio and optimize it to the purpose to which you're putting it. We then put it into the DVB portion of the diagram, into the bit stream, which pass through either over a broadcast medium or possibly a physical medium or a file, and it's delivered to playback in the home. Now, this really represents the whole of the audio entity. It's receiving individual pieces of audio with all that metadata about them into the renderer, but it's also receiving traditional presentations of different channels. So you can build up from either archive content that's got channel content, or you can use your standard workflow where you might create beds of audio using channels for international distribution and for your underlying infrastructure. And then you can put your special experiences in terms of audio objects rendered on top. The render in its totality will then sum those together to produce the presentation to the listener. And in this particular example, our listener is at home with a home cinema system. They've got a 9.1 system. The renderer, the playback system knows that and is able to derive those 10 different speaker feeds. But easily, the same bit stream, if presented to a renderer that knows that it's only got 4 speakers or just a standard stereo 2 speakers, it would know what to do with all those components to give the optimum audio presentation with the number of speakers available. And this includes things like binaural. So you can put binaural renderers in the renderer at the end. All these components can then be put into a special experience so you get an immersive sensation over headphones. So that's one component. That's the audio path, if you like. The other key concept that's part of DVB is the idea of pre-selections. So we've kind of expanded this amazing audio palette of opportunities, but that's going to present us with two problems. There are now so many choices, possibly, it's going to confuse the users, particularly on small screens or even on television interfaces. It's going to be very difficult to manage all of those. But also, in terms of what you want to do, in terms of your proposition to your audience, your creative intent, you want to be able to manage those options. And this is where the notion of pre-selections comes in. So what you can do is you can combine the key components in the way that you want and offer those up to your audience. So if you've got a default presentation, as you have in the top one of these, which is in English, you can offer your sound effects, your M&E, and your dialogue in English. But you might want to offer some German members of your audience a version that's tailored to them. So you take the same basic M&E component with all your underlying sound effects and music, and you add a German dialogue. But you might want to offer a pre-selection that enables your English audience to have some audio description. So in this particular one, for those people who have a hearing impairment and want a visual impairment rather, and they want somebody to describe the scene for them, you can add that so that that person can go to the English audio description pre-selection, and they'll get three components delivered to their loudspeakers. Once again, you've got the M&E, the dialogue, and the audio description. Or you might want to offer a slightly different presentation altogether, and give them the option to hear, say, if it's a cycling or a motor racing event, the radio traffic that's going on between the competitors and their supporting. So you can give that as another pre-selection. Or if you're using this perhaps in a business domain and you're offering services to other broadcasters, handing off a bit stream, you might just want to offer the M&E pre-selection so they can pick up all that sound effects and music, and then they can add at a later date their own dialogue and their own additional audio features. But this content doesn't just have to be delivered all over the broadcast bit stream. It's quite possible to have hybrid delivery, and if we go back to those commercial requirements that we talked about back at the beginning, you'll find that one of the key requirements there is to be able to have hybrid delivery. This particular slide shows us how that might combine delivery over dash with the broadcast bit stream. At the top you can see the broadcast bit stream. I particularly like this diagram because it appears from this picture that from the total bandwidth available to us, the video has been squeezed to a tiny, tiny, tiny bit at the top, and audio is taken over, and we've got lots of rich audio loveliness in the main bit stream. Unfortunately, it's a graphical representation just to allow us to explain the concept, probably not the reality. But down below that, we've got the dash bit stream with those extra dialogue and commentary components in different languages being added. Let's expand on that a little bit more and look at some of the delivery possibilities. So the top one shows a broadcast bit stream, and inside that bit stream are all those components that we've explored already. Underneath, though, we've got a multi-PID bit stream. So if you're looking to link the capacity that you've got available on your broadcast platforms in a new way to be more efficient or to add extra possibilities, then you can link to other streams across the multiplex using multiple PIDs. Or we come at the bottom to the hybrid delivery case, where our essential main components are delivered over the broadcast bit stream, but the enhancing components, the extra dialogue in alternative languages, the team radio, the audio description, is synced up from maybe a dash bit stream, and allowing your receiver to use the two different platforms to offer the full experience. So, efficient use of bandwidth, absolutely key. This is a photograph of a bazaar. In fact, it's in Constantinople. And it's an ancient building. I can't remember the exact date, but a bit like the broadcast spectrum, we've got a defined amount of space available to us. And over time, as our needs and as our desires and as our want for variety increases, we make more and more efficient use, and we get more and more into that space. And that's what this slide is trying to show us. So not only have we added all this extra capability, but all those audio codecs have improved in their efficiency as well. So we're able to get just as good audio quality into the same sort of space, as well as adding all these extra capabilities and much more sophisticated way of delivering hybrid experiences to improve the efficient use of bandwidth. Other system benefits, a beautiful piece of animation here, but there's a kind of gearbox effects of lots of things meshing together to improve the sophistication of what is possible. So in this case, we can see that we can deliver multi-stream delivery, as we've just been discussing, but we've also got much more sophisticated techniques for handling the loudness of all these different components, so that we can maintain overall program loudness in the loudspeakers and in people's ears. We can also handle multi-device capabilities, so multi-device dynamic range control, so that depending on the sort of device you're listening at, you don't just send one set of presets for the dynamics range control. You can invoke different dynamic range control technologies depending on the device. And a lot of this is improved through quite sophisticated signaling that's all part of the DVB specification. But this doesn't stand alone. It's not all about what happens in DVB, although that's a really important part of the ecosystem. This is indeed just that. It's an ecosystem. And here is a fantastic picture that shows no broadcasting whatsoever, but it does show an ecosystem. And the point that we were quite keen to share with you guys about this is that the DVB bitstream, although it's core and it sits in the middle of what is happening, there's a whole load of stuff that's happening around the edges to make this very usable in broadcasting right now. So there's a range of receivers capable, so screens, AV amps, soundbars and that sort of thing being produced with this technology in. We reckon somewhere in about half of most of the new displays being sold, that's the UHD displays being sold in Europe, probably a bit over that, have at least one of these technologies inside them already. And by kind of 2020, we expect pretty much every UHD device being sold in Europe to have at least one of these inside it, some NGA capability. Other organizations are also working on the standardization of all the components that you need. So the SMPTE have been busy working on NGA and incorporating that into their standards and specifications. Similarly, the ITU. We're very close to having a standardized renderer from the ITU. And the ITU have also standardized another really key component of the ecosystem, which is an open standard object-based technology called the audio definition ADM. The audio definition technology is ideal for open standard production and program interchange. I know that something else that's being looked at is incorporating NGA technologies into the interoperable mastering format, into IMF, which is one of the SMPTE specifications. We have production tool manufacturers from digital audio workstations, mixer technologies, storage and recording companies, all now beginning to look at implementing some of these next generation technologies. So a whole ecosystem from being able to produce, deliver and receive ADM is now complete. So in principle, guys, thank you for listening. I said I'd try and get this done in half an hour, and we pretty much achieved that. It's an opportunity to ask some questions, if that's okay.
Yes, Simon, thank you very much. I think this was a marvelous tour through the wonderful world of NGA. And I think it's fair to say that compared to the previous audio schemes, NGA is really a quantum leap forward. I forgot to mention in the beginning that, of course, the slides and the recording of this webinar will be made available on the DVB website, dvb.org. So just look out on our website under events, and eventually, probably very soon, maybe even today, you will see the information about this webinar. And yes, everybody is invited to provide questions. You can type in the questions under the Q&A on the WebEx interface. And while the audience is thinking about the questions, I have one question to you, Simon. I mean, you told about the ecosystem of NGA. When will broadcasters start to provide NGA services in their transmission?
So we are beginning to see some of the global platforms adopting the DVB bitstream as part of their offering. We already have some of the sister implementations in ATSC being adopted, particularly in Korea, who launched NGA services to go with the Winter Olympics a year ago. And there are trials and pilots of the technology going on all over the place. So there's activity in France. There are services using some of the early variant immersive stuff in the UK, particularly around sport, football, that sort of thing, from both BT and Sky in the UK. There's activity in the Nordic group in Scandinavia, some in Italy. So people are beginning to experiment with this, and it's not just about the broadcast technology as well, it's about the streamed services using the MPEG- variant. So people are experimenting making the content, and people are experimenting with the delivery platforms and trying to find out what the receivers in people's homes are capable of. And that includes, some of the headphone content, the binaural I talked about. So BBC certainly has done a couple of dramas. We did a Christmas drama version of a Charles Dickens play that was designed to be rendered to binaural using NGA techniques this Christmas. And the year before that, we did a version of our science fiction drama, Doctor Who, using signal slaughter techniques. So I hope that answers that question, Peter.
Yeah. Okay, so it sounds very promising. I got another question from the audience, and I just read out the question. This sounds like it could require a lot of change in broadcast production and infrastructure. Are there ways to move to NGA step by step?
So I think that's a really good question, because it does sound like there's a lot to do, and you can indeed do it incrementally. Some of this can be done on a program by program basis. Some of this can be done on a platform by platform or service by service basis. There are a range of technologies that allow you to transport these new signals over your existing infrastructure in the same sort of way that when we wanted to try and get 5.1 down stereo pipes, people like Dolby with their famous E solution and others came up with ways to help us do that. And there are a number of people developing techniques that allow you to exploit your MADI connections or similar to move NGA signals around. And it's not a trivial challenge. I wouldn't give anybody the impression that this is going to be really easy to do. It's going to require a bit of effort, because what you're attempting to do is take quality metadata, technical metadata, and sometimes descriptive metadata, and take it from the point of capture and get it all the way through to the home. And I think most of us who have tried to move metadata around in our organizations know that this is not trivial, but it's not a challenge we can shy away from. If we really want content that's going to exploit the capabilities of hybrid delivery and broadband delivery, we're going to have to master this, and you can bet that a lot of people out there know that they are going to get both a better experience for their audiences and thereby have a competitive advantage by being able to master the end-to-end challenge of moving metadata around. So there are a lot of people out there working quite hard on absorbing this into their organizations.
Okay, thank you very much. Yeah, so this looks good. So while the audience is still thinking about questions, I have another question. When I was following the discussions on NGA, I was always very impressed by this concept of a renderer. So you basically give this magic device several audio channels, and then with some magic, the renderer generates audio signals for the speaker system in the room, and somehow takes also into account how many speakers there are in the room and potentially even their location and position. You said it's necessary, you mentioned that ITU is standardizing the renderer. So just a question from my side, is it necessary to specify such a renderer, or is this something which can be left to the market forces?
So I think it depends what you're trying to achieve and at what point in your signal path you're talking about. The renderer is a complicated and, to many people, a new concept. We think at the moment, and if you look at that EBU document that we showed earlier on, I think it's R151, this is kind of explored a little bit by the EBU team. Obviously, for broadcasters, it's quite important that they have a common presentation that they can understand and build their creative vision around across their organization. So from OB trucks in the field, through dubbing streets, through playout suites and that sort of thing. And this is where the standardized renderer is really important. It allows you to give all the people involved in production across the production chain a standard view of NGA. But if we just sat there with that, then all the possibilities that NGA offered would be kind of throttled back. We wouldn't see new experiences or improvements emerging. And I think this is where the DVB component becomes much more important, so that the receiver in the home is able to iterate through the technology cycle and adopt new approaches to try and enhance those experiences, make them easier to use, and giving the experience over devices that we haven't yet even conceived. It's not that long ago, and I know everybody says this, that we didn't have flat screen televisions and we didn't have tablet devices. So being able to render into those environments is obviously a given now. Who knows what the next set of experiences might be like, or devices might be like. So I think there's a bit of both inside the ecosystem. You have to have the confidence in the way you produce your content. At one end, you have to be able to innovate and give new and exciting experience to your audience at the other. Hopefully that kind of covers that, Peter.
Okay, no, thank you very much. I think that was a very good answer, and it shows on the one side that some standardization is necessary to give the broadcasters a way to represent the audio which will come to the end user. But on the other side, of course, we should also be open to further improvement and new features for the renderer. And I can imagine that one day all the audio magazines of this world will provide test reports about the renderer.
I think one of the other interesting things as well, Peter, if we look at the history of audio, the first set of audio recordings, the first viable audio device was Edison with a phonogram back in, in the early 1880s. And then there wasn't really a significant development in audio technology that was widespread adoption until the 1930s, when people started to discover and explore stereo. And you get the work of people like Alan Blumlein at Decca, describing something that in many ways, if you look at his patents of the 1930s, described what became the cinema, the immersive surround sound cinema experience of the 1990s. And Blumlein was describing that back in the 1930s. So there have only really been two huge and significant kind of steps in some ways to audio. And this is potentially the third. This is, they come along once every 70 years. This is the third one. And it's a fundamental change in the way we potentially do audio, and it offers a complete new range of experiences for our audience, just by the simple exponent really of adding a lot of descriptive and controlling metadata to the process that we operate.
Yes, I totally agree. This for sure is a completely new way to present audio to the end users. And I think, yes, I like your information about the third generation of this. I got another question, which I regard as quite interesting. And the question is about synchronization of audio channels when you have a hybrid delivery model, meaning when the audio can come via the broadcast channel and through the broadband channel. How do you cover time differences in these delivery mode?
So I think this is getting to the edge of what we were intending to talk about on this WebEx, and probably not an area particularly of my expertise. It is obviously defined in the standards that we talked about earlier. Synchronization is obviously has been a significant challenge for broadcast television for a while. The expectation is that we'll be able to improve synchronization with this technology. But some of my supporting colleagues are probably best a better place than I am to be able to answer that. In some ways, I guess as well. Sorry, Peter.
Wolfgang pointed out you should mention TEMI mechanisms. TEMI.
He has, and I'm not sure what he's talking about. So that's slightly embarrassing. Probably he'll give me a steer, and I'll go, oh yeah, he means.
Okay, TEMI is a timeline mechanism defined together with the impact to transport stream, so that you have a timeline where you can reference events too.
So there you go. Thank you.
Okay, yes, but I think it will be an interesting experience in the future when we have the combination of more hybrid broadband and broadcast, how to synchronize the streams, and maybe we have to introduce a certain delay in the broadcast in order to compensate for delivery via the broadband channels.
I think that's almost inevitable, yes. I guess one of the other things that we should probably introduce to this is hopefully if I can get this to work, there we go, a final slide, because people might want to go find out a bit more about this sort of stuff and talk to some of the guys from Dolby, Fraunhofer and DTS. And the next opportunity to be able to do that is obviously NAB. So to help people go and take their journey with NGA to the next step, as it were, we produced this slide which will tell you where you can go and find those guys at NAB and potentially as well at IBC in September if you're not going to Vegas. So I would definitely recommend that you go and experience it. Like a lot of these things, it's much better listened to than it is talked about. So go and have a listen. And these guys will be able to talk you through the way that their particular approach unlocks the benefits that we've explored earlier in the presentation. So if you get the chance, guys, go and talk to one of these people at the forthcoming trade shows this year.
Yeah, thank you very much, Simon. Yes, and I totally agree. I think it's in this case only hearing is believing. So I would also encourage everybody who has a chance to be at these upcoming trade shows to visit the proponents and to get a real feeling and experience on what these new audio systems can do. I had the opportunity to experience quite a lot, and I can really say it's a breathtaking experience.
And the range of products available for consumers, obviously there were a number of product launches at the beginning of the year at CES, but we're expecting more and more of these things at a range of different price points, from the super high-end ultimate experience through to very affordable experiences in displays, AV amps, soundbars particularly, and other sort of speaker arrays all the way through. So yeah, thank you very much for listening, I guess.
Okay, good. Yeah.
We got to the question.
Okay, I see.
Wolfgang
at the moment.
Oh yes, we've got another question down there. I'll get rid of the cat that's waving goodbye. Wolfgang was very insistent that we had to include the cat, but we'll hop back to this.
Okay, there's one more question. What is the name of the new audio format? That's a good question. Yeah, can you comment on this, Simon?
Well, we're calling it Next Generation Audio NGA as a kind of industry blanket term to describe the bringing together of the object, channel, and scene-based audio technologies into a bit stream. It's not a perfect name, I have to agree. What comes after the next generation? What is the next generation to the next generation? It's the term that's in current use. Obviously, all the technology providers have their own sort of brands and names for their particular experiences and what the magic that they introduce in the receiver at the home. And I would certainly be interested to see if slightly more accessible or exciting terms could be used to describe it. But at the moment, NGA or Next Generation Audio seems to be the term that this ecosystem is clustered around.